All right, hello again, everybody. So on Monday and Tuesday of this week, we talked about some of the characteristics of a quadratic graph. All the ones we did on Monday and Tuesday, the graph opened up, or the U was basically right side up. Today we're going to talk about some of the quadratic graphs that open down, or the U is upside down. First of all, what makes that happen? Well, this graph right here is for this equation right here, which is y equals negative x squared. That negative in front of the x squared, or the negative in front of the a term, is what makes our parabola open down. So looking at this graph, here's my x-axis right here, and there's my y-axis right there. We're not going to spend a whole lot of time with this because if you remember on Monday and Tuesday, since there's nothing over here, well then my vertex was 0, 0, and then that becomes the answer for a lot of my information down there. So we're going to speed through this one. Like I said, since there's nothing out here, it doesn't move. The only thing that happens to what we called the parent graph was it flipped from opening up to opening down. All right, so let's move on to another one. All right, so this graph here, here's my x-axis, here's my y-axis, here's the equation that created that graph, y equals negative x squared plus 2x plus 3. So first let's find our vertex. Remember, our vertex is going to be where my U changes direction, and it is right there. And that vertex right there is at 1, 4. I don't know if you can see that, but that's 1 and that's 4. So 1, 4. Remember, it opens down, so that's what makes it open down, is that negative out in front. My axis of symmetry, if I were to draw it, would go right through the vertex. And remember, we have to write that as x equals whatever that line, or wherever that line crosses the x-axis. But remember, it's always going to be the same as that number right there. Next, let's find our roots. Well, remember, we can call that our x-intercepts or our solutions, but our roots are where it crosses the x-axis, which is right there and right there, and that would be at negative 1 and 3. And then our y-intercept, or where it crosses the y-axis, is right there. So it crosses where y is 3, but we need to write it as a coordinate pair, so it's going to be 0, 3. All right. So one more, and then we'll be finished, and you can go on to your worksheet. So our last one, the equation that created this graph is y equals negative x squared plus 2x minus 3. Again, that negative right out front, or the a being negative, is what makes this graph open down. Here's my x-axis, here's my y-axis. Let's find our vertex, which is right there, and that's going to be at 1, negative 2. 1, negative 2. Axis of symmetry goes right through the middle of the vertex. We need to write it as x equals. It would cross the x-axis at 1, or again, that number right there, the x value of our vertex will always be what goes right there. So now let's talk about our roots, or our x-intercepts, or our solutions. Well, if the x-axis is up here and this opens down, if it keeps going down this way, then it will never touch the x-axis. So put none. Do not put 0, because if you put 0, you're telling me it crosses right there. Tell me none, or even not applicable. Finally, let's find our y-intercept. There it is right there. 0, it crosses the y at negative 3. So there is that. All right, so that's it. This is the last video for the week. do your assignment for Wednesday and Thursday. Next week we'll dive into some more things we can do with these equations, finding the vertex without seeing a graph and maybe things like that. For those of you that continue to work, thank you, Miss Winter, and I really, really appreciate it. And you're really only doing yourself a favor, because in the long run, you're going to be ahead of the game probably next year in your geometry or algebra 2 class, especially in your junior year. All right, so do your work and look for more videos next week.